Synthetic division. In this video, you will learn how to divide any polynomial p of x by a linear polynomial such as x minus c. And here are the steps in synthetic division. First, identify the constant c of the divisor x minus c, and this can be done by restating x minus c to x equals c. The next, write only the coefficients of the polynomial p of x, and we should write a 0 for the coefficient of the missing term. And for number 3, bring the first coefficient or the leading coefficient down and multiply it with the constant c. And for number 4, add the product obtained in step 3 to the next coefficient. For number 5, repeat these steps 3 and 4 until the last coefficient is obtained. And for number 6, the last coefficient is the remainder, while the remaining coefficients determines the coefficients of the quotient q of x. And for number 7, the literal coefficients and the exponents of the quotient q of x are determined by reducing the degree of the polynomial p of x by 1, for which the degree of the quotient is given by the degree of p of x minus 1. So remember that synthetic division is relatively easy by doing this with an example. And let us proceed with this problem. So divide this polynomial by x plus 3. So the first step is to identify the constant in our divisor, such as x plus 3. So doing so, we have to equate such divisor with 0, and we should have this be written in terms of the value of x. And applying the addition property of equality, we should add to both sides a negative 3, so that our resulting equation would now be x equals a negative 3. So this negative 3 will now be used in our synthetic division. But before we do that, we should make an inspection first with our polynomial. Here you will notice that the polynomial is not written in the proper order. We should consider the highest exponent first, having the highest exponent of 5 be written first, such as negative x raised to 5, followed by the next term of negative 2x cubed, so followed by positive 3x squared, and here we have a negative x plus 4. But you will notice that this polynomial expression has a missing term. So normally, we can easily notice that by looking at the highest exponent and continuously reducing such exponent by 1 until the constant term. So having our 5, usually this will be followed by a 4, but in this case, the exponent of 4 is missing. So notice that there is a gap between this exponent of 5 and this exponent of 3. So remember that in the steps, we should supply or write a 0 for such missing term. Doing so, we have a negative x raised to 5, having the term containing the exponent of 4 having a coefficient of 0, then we will have this to be 0x raised to 4, followed by negative 2x cubed plus 3x squared minus x plus 4. And since we have this polynomial written in the proper order, as well as having a 0 for the missing term, then we can now set up the coefficients of our polynomial in the synthetic division process. Having this value of negative 3 written first, like this, and now writing all the coefficients of this polynomial, having a negative 1 here, followed by a 0, followed by a negative 2, positive 3, negative 1, and the constant 4. So the synthetic division usually comes with three rows, such as the coefficients here, and another row of values here, and another row of values here. And now for our third step, we should bring this first coefficient down here, writing negative 1. And for our next step, we should have this number be multiplied with the constant. So having our negative 1 times negative 3, we have a product of positive 3. And for the next step, we should have this product be added to this coefficient, which gives us a positive 3. And for our next step, we only have to repeat such procedure until the last number is determined here. Doing so, we have our 3 be multiplied with negative 3, and we have a product of negative 9. Adding these two numbers together, we have a negative 11, and multiplying the negative 11 with the negative 3, we have a positive 33. And adding these two numbers together, we have a 36. And 36 multiplied with negative 3, we have a product of negative 108. And adding these two numbers together, we have a negative 109. And finally, we have to multiply the negative 109 to negative 3, and we will have a product of positive 327. So adding this together, we have 331. And now, to have the quotient, we should always remember that the last number here represents the remainder, while the remaining coefficients are the coefficients of our quotient q of x. So normally, we are writing the quotient by having the literal coefficients of x with an exponent of the degree of such polynomial p of x, which happens to be the highest exponent 5, reduced by 1. So having this coefficient of negative 1, writing the variable x being raised to 4. So remember, we only reduce the degree of our polynomial by 1 for us to have this exponent of 4. But since we have an expression of negative 1x raised to 4, we should only write such expression as negative x raised to 4. And for our next coefficient, we have a positive 3. And we only need to reduce such exponent of 4 by another one, having our x to have an exponent of 3. And we only have to repeat such procedure, having our next coefficient to have a negative 11. So writing the x, so this time 3 minus 1 is 2. And for our next coefficient, we have a 36, followed by x, and this time 2 minus 1 is 1. But we should not write the 1 anymore here. And finally, we have the negative 109 being the constant term of this quotient. But normally, we are writing our final answer to have the remainder be written as 331 over the divisor, which is x plus 3. So this will be our answer to such question of dividing these two polynomials. And for our next example, so here we have to divide this polynomial by x minus 2. So let us have first the value of c by equating the divisor with a 0 and applying APE to find the value of x. We have to add a positive 2 to both sides of the equal sign, giving us x equals 2. So having this value in our coefficient setup here, and for the coefficients of the polynomial p of x, here you will notice that the polynomial has complete terms. So writing immediately the coefficients of this polynomial, we have the first one be positive 3, The next one to be negative 5. Here we have a positive 2. And next would be negative 6. And let us start with our synthetic division. So let us bring the first coefficient down and multiplying this immediately with 2, it gives us 6. And adding these two numbers together, we will have a sum of positive 1. Again, multiplying this with 2, it gives us a 2. And adding these two numbers, we have a positive 4. And multiplying this with positive 2, it gives us 8. And adding this together, it gives us a remainder of positive 2. And for our coefficient, we have to write the first coefficient here while having the variable of x be raised to the exponent of reducing this first by 1. We will have a 2. And for the next coefficient, we have a positive 1. So writing only the x. And this time, reducing this by 1, it gives us a positive 1. So again, we should not write the exponent of 1 anymore. And here is the constant term of the quotient. Since we still have a remainder, we should have this remainder be written like this. So remember, this is the divisor x minus 2.